2.2c, and this is the third video or 2.2, and we're going to finish up. We've just got, looks like about 4 examples to go over, and there's just some tricks with some of these examples that I want to make sure you've got as we're going along here. So this is example 8, middle of page 123, and one of the things I want you to notice when you're doing these is, first of all, we are trying to set this equal to x, or solve for x, which means our goal here, since we have 1, 2, 3 variables here, we cannot find a number to represent x. We're just going to rearrange this so that it ends up being x equals something. So one of the things you want to look at when you're looking at these equations here is to see if there are multiple times the variable you're looking for is showing up in the equation. So here we've got it, and over here we have an x. So when that's the case, the biggest thing we're trying to do is get everything that has x's in it on one side of the equal sign and everything else on the other side, and then we get rid of things that are attached to the x. So for instance, and that's kind of hard to understand what I'm saying there, let's move this over to the left-hand side so that we have all the x's on the same side. Okay, so next step is we continue to get rid of things except the x. All right, so now we have that. One of the things that's important is we cannot separate, or we cannot combine these two. Usually when we have something like 4x minus 3x, we get 1x because we subtract these. But when we have variables in front of the x, we don't know what number that represents. Each of those numbers represent for a and b, so we can't subtract them. I mean, I suppose we could do this. Subtract those with the x there, but it doesn't give us anything. It doesn't help us with anything. So what we end up doing is looking to see if we can factor anything out. And we can factor an x out, and we're left with a minus b, which is very similar to what I just had on the whiteboard, only the other way around. So we can continue on with this because we can now get rid of this here. Because it's in the parentheses, it is one unit. It's one piece. So if we divide both sides by a minus b, then we can cancel that with that, and we have x equals 8 over a minus b, and that is as good as it gets. Can't go any further than that. Bringing us to example number 9, which is y minus b over x minus 0, and that equals m. And what they're asking us to do is find y. So we're supposed to get rid of everything on the left-hand side except the y. So that brings us to trying to get rid of everything that we can. So where do we start? First of all, what I want you to notice is the denominator, x minus 0. We're subtracting 0. You can't subtract, I mean, when you subtract 0, nothing happens, so we can just get rid of that. And we've already simplified it. Now again, we're trying to find y. We've got to keep on task of what we're trying to do. So when we have an x or anything in the denominator, we multiply both sides by that, and it will make those disappear. So we've got y minus b equals mx. And again, we're looking for y, so we're going to add b to both sides, and we get y equals mx plus b for an answer. So as we continue on, we're in example 10. Again, we're trying to find y here. But this one's a little bit different because on the last one we had x minus 0, so we just got rid of that and went on. But when we did take away, when that was, in fact, let's put it there again. When we did have x minus 0 and we got rid of that, what did we do to both sides? We multiplied by x, or we multiplied by whatever was in the denominator. All right, so let's get back to where we were, and let's do that exact same thing. We're going to multiply by the denominator. This time it's x minus 5 and x minus 5, which on the left-hand side is fine because we just cancel those. Those just go away. So now we're left with, equals 3 times x minus 5. Now we have to get rid of this 4. So we're going to add 4 to both sides. So we have y equals 3 times x minus 5 plus 4. And then let's go ahead and distribute that 3 just to get rid of our parentheses. And that does help us to simplify because now we can combine those and get y equals 3x minus 11. And that's what y equals. That looks a lot prettier than this mess up there. So by being able to simplify or to change things around a little bit makes our equation a lot easier and a lot more usable, especially, let me write the answer here again, in this form. Later on, we will be using equations that have a y on the left, an x here with a number in front of it, and then just a number at the end here. So it's good to be able to solve for y so that you can get it in that form because, like I say, down the road, we will need it in that form because we're going to get into a lot more graphing. So last one, example number 11, we have s equals 2 pi rh plus 2 pi r squared. And we're solving for h. So we need to get all of this and all of this over here so that we just have an h there. So what I usually tell students to do is let's get rid of the things that are furthest away from what we're looking for. So we have a 2 pi rh. These are all multiplied. Not going to do anything with that. We're going to get rid of this first because it's furthest away from the h. So you're trying to get things away from the h that are added or subtracted to the h first. So this is, we're going to subtract 2 pi r squared. Now notice what I did here. I am getting rid of the whole shebang here. These are all multiplied together. So that means they're all connected. They're all hooked together so I can get rid of them at the same time. And that makes it a lot less writing than trying to do it one at a time. So now I have s minus 2 pi r squared equals 2 pi r h. Okay, so at this point, we are in a nice place because everything else over here with h is multiplied. So if you want to get things that are multiplied by h, you divide both sides. Now again, these are connected together with multiplication signs, so we can divide those out all at the same time. And then we do this, 2 pi r. Remember, when you divide both sides by this, you divide the entire thing by this, not just the h, not the 2 pi r squared. And then we're done. So because we divided these out, those go away, and we're left with our h on the right-hand side, which is what we're looking for. But one thing I do want to bring up, a lot of students will look and say, oh, we have a 2 and a 2, a pi and a pi, and an r and an r. I can cancel a bunch of this. You cannot cancel anything in the numerator with anything in the denominator if there is a plus or minus sign before or after them. So this means that there's a minus sign in front here. That means you cannot cancel this stuff with this stuff because this 2 pi r squared is connected to the S. It's kind of like this is a chain link. It's holding these two together. So therefore, you cannot cancel. If, for instance, this was gone, or even if there was a minus sign here, you can cancel because it's not linked to anything over here. There's nothing over here. There's not a 1. There's not anything. So now I can cancel the 2 and the 2 and the pi and the pi. But as soon as you put something there, whether it's a letter or a number, you're not able to cancel. And you're left with this as your answer. So you don't have to go any further. All right, so that's 2.2C.